This video is going to introduce the concept of the power of a test. So we just talked about a type 1 and type 2 error, and the power of a test is actually the opposite of a type 2 error. So if you recall, a type 2 error was fail to reject the null when the alternative hypothesis is true. So think about what our goal is as a researcher. Our goal is to reject the null and rule in favor of the alternative if the alternative hypothesis is true. So the type 2 error is when you fail to reject the null when the alternative is true. So the opposite of that is actually called the power of the test. The power of the test is the probability of correctly rejecting the null. Specifically, it says it is the probability that the test will find convincing evidence for HA. Okay, so it really is the probability of correctly rejecting the null and ruling in favor of HA. So the type 2 is when you don't reject the null when you should have, and the power of the test is you do reject the null when you should have. So power is a correct decision. The type 2 error is you fail to do the right decision, okay? So that's their relationship between the power of the test and the type 2 error. So here's an example. You guys remember the one with the AAA batteries. So if we had done a type 2 error, we would have failed to reject the null when the HA was true. So that would have been, we claimed that the battery length was 30 hours and it was the same as the standard battery, when the truth was that indeed these batteries last longer. Okay, that would be a type 2 error. Well, they calculated the power of the test for this question, and they got a power of 0.762 for the true mean of 31 hours. So they got 0.762. They really do last longer. So the power, it says interpret it in context, the power is the probability of correctly rejecting the null in this setting. So 76.2% of the time, we will correctly reject the null hypothesis and conclude the batteries do last longer than the average of 30 hours. So it's the probability of correctly rejecting the null. 76.2% of the time, we are going to reject the null correctly. So for this specific mean that they said, indeed, it lasts more than 30 hours, it lasts 31 hours, that is the probability we would correctly reject the null. So we'd say for a true mean value of 31 hours. Okay, so we're proving that indeed that these batteries last longer. Now, what is the relationship of power to the type 2 error? Well, I said it above. The power and the type 2 error are actually complements. So 1 minus a type 2 error is the power, and 1 minus the power is the type 2 error. So as the power goes up, this is an inverse relationship. As the power increases, the probability of the type 2 error will decrease, and vice versa. So you're either correctly rejecting the null or you're not correctly rejecting the null. So you're either doing one thing or the other. Now, there are specific ways that we can increase the power. Remember, the power is the probability of rejecting the null when HA is true. Okay, so how can we increase power? This is not, I don't think this is on your worksheet, but just throw it in somewhere. How can we increase the probability of rejecting the null. So when do we reject the null? We reject the null when P is low, right? Lower than alpha, right? When P is low, reject HO. So how can we increase the probability of rejecting the null? Well, option 1, increase the alpha level. Okay, so let me explain. Let's say alpha equals 0.01. The probability of rejecting the null would be the power, right? Okay, so P would have to be less than 0.01 for me to reject the null in that setting. P would have to be very low for it to be lower than 0.01. But if we increase the alpha level to 0.05, now the p-value will have to be less than 0.05. This is slightly easier to do because the p-value doesn't have to be as rare for me to reject the null. So if you increase the alpha level, it will be easier for me to reject the null and increase the power of the test. The second one, increase the sample size. Remember, when in doubt, you want to increase the sample size. The bigger the sample size, what happens? Let's see. As n increases, standard deviation of the sampling distribution decreases. As standard deviation decreases, the values get closer together and the graph gets narrower and taller. As the graph gets narrower, the probability of rejecting the null will actually increase because the p-value will decrease. So think about the tail here, the tail of this one versus the tail of this one. As it gets a narrower graph, the p-value will be smaller. And the p-value is smaller, it's more likely it will be less than the alpha level, and you'll be more likely to reject the null. So if you increase the sample size, the standard deviation decreases. As the standard deviation decreases, the graph gets narrower, the p-value gets smaller, and then it will be more likely to be less than alpha. So more likely to be less than alpha, more likely to reject the null. Now the last thing that might happen is in the previous question it said the power of the test for a true mean of 31 hours. If you recall, the null was 30 hours for the AAA battery question here, and then they said underneath the new batteries are more expensive. They want to find that they really do last longer. The power of the test to detect that mu equals 31 hours is 0.762. So if the true mean were really 31, the power was 0.762. Where is 31 with respect to mu? Well, the mean was 30 in the center, so 31 would be further away from the center, right? So let's say we wanted the power of something like mu equals 32. The true mean was 32 hours. 32 would be even further away from the center. Further away, lower p-value. Lower p-value, more likely to reject the null. More likely to reject the null, higher power. So pick a value for the true parameter that is further from the center. Further from the center, lower p-value. Lower p-value, less than alpha. Less than alpha, more likely to reject the null. So if you remember these facts, this is going to help you to answer any questions that involve power on the AP exam. All right, so let's look at an example. This example was a test of patients who get nauseous from taking a specific drug that is for Alzheimer's disease, sorry. They did a test of significance at the alpha equals 0.05 level, and they got a power value of 0.29. So it says determine whether each of the following changes would increase or decrease the power of the test. So they used an alpha level of 0.05, and they got a power value of 0.29. What happens if they change the alpha level from 0.05 to 0.01? So if they decrease alpha, then the p-value it would be harder to reject the null because p would have to be less than 0.01 instead of 0.05. So this is harder to do because the p-value would have to be even lower. So the power will go down because it's going to be more challenging to reject the null at the 0.01 level than the 0.05 level. Now, what about if the true proportion, they're telling you that the true proportion was 0.08. So they're saying, what if it was 0.06 instead of 0.08? So if you look back at the null was 0.10. Okay, so it was centered at 0.10. So draw a bell curve, label mu sub p hat equals p equals 0.10 for the p sub 0. So it was 0.08 originally, was the true value, and the power was up above given to us as 0.29. And they're saying, what if we made the value 0.06 instead for the true value? Well, 0.06, 0.08, sorry, to 0.06. 0.06 is even further away from, further into the tail and further away from the center. Further away from the center means the p-value will go down. P-value decreases means power increases. So if you pick a value further away from the center, the p-value will get smaller. As p-value gets smaller, it's more likely to reject the null, so the power increases. And lastly, they used a sample here of 300. And they're saying, what if we used a sample of 200 instead of 300? So if we decrease the sample size, then we are going to increase the standard deviation. So it's going to get wider. And therefore the power will go down. Remember, if you increase the sample size, the power will go up. So if you decrease the sample size, the power will go down. So here's an example, multiple choice, which of the following are true. First one, power is the complement of a type 2 error. This is true. This is the definition of power, and it is the complement of a type 2 error. Second one, as we increase the sample size, we increase the power. This is also true. That is one of the facts that we just went over. And lastly, a test with higher power is more likely to reject a false null. This is also true, this definition of power. So all of these are true. Now the next multiple choice, you guys, we're going to do in class when we get back. So you can stop the video here.